So next on our agenda is Falk Bleyl. He's the CTO and co-founder at Utopi, a Scottish-based tech business. He's got 20 years experience in IT, telco, IoT, and really focused right now on environmental, social, and governance software as a service. He'll tell us stories far better than I will. What I will say is this is one slot where we don't have time allocated for Q&A, but you can always catch him at the end. So thank you, over to you.
Thank you. It's good to be with you today, and I'm going to preempt a question that may be on some of your minds, and that is, why do I look like a cross between the Joker and the Phantom of the Opera without a mask? And it's not that I didn't apply my lipstick properly, but it has to do with a sunburn that's not been very kind to me. So that's that. So just in case, I wanted to take that distraction away before anything else. So just perhaps before I start talking about our journey with CENSIS when it comes to the development of some hardware and our technology, I will tell you a little bit about Utopi as a company. The company has been in existence for about 3 years now, and we help multi-tenant investors, owners, and operators of residential buildings to operate their buildings more efficiently, to reduce and eliminate waste, and also help to reduce emissions as a consequence. We are based in Hamilton in Scotland, and we have a UK-based, primarily Scottish-based workforce. So what we do is effectively we take data from a variety of sources, and the sensor that I'll talk about in a minute is an essential part of that, and also metering data and some other data points into our platform. We then analyze that data, and we present it and organize it for our customers. We then create alerts if certain metrics and values go beyond that. We refer to that as the U-bot, and as a German, I have to be very careful how I pronounce that. It's one of my colleagues that came up with the U-bot, but I like it. I can still talk about world domination, and I'm sorry you can't. So we do create alerts based on the data, and we do that in near or real time. And we provide ESG reports also for our clients, and that gives them direct and significant insight into their buildings that previously they had no direct visibility of. And ultimately, what we do is we actually engage with the residents in those spaces also, where they can see their performance and the performance of the spaces that they live in, their apartments, and we help them and coach them and give them hints and tips as to how they can avoid waste and how they can have as healthy and as an efficient an environment as possible. So in order to do that, one of the things that we worked on and that we did specifically is we decided that we needed a device that would be able to capture this kind of information in a residential environment. And when I spoke to the team that we assembled, and that team was made up of a variety of different organizations, CENSIS had a central part in that to help with some of the prototype work and prototype development, and specifically also the firmware for the device, the test and commissioning firmware also, and software. And we brought other parties together at that time, expert organizations in their own field. In fact, some of them are represented here today in the auditorium. We have Orvio, who helped us with the hardware design. We had Champ Industrial Design as an industrial designer who helped us actually with the physical design of the device and the case as such. We had CB Technology as our manufacturing partner, who actually manufactured the device on our behalf in Livingston. And we also worked closely with a company called Glossbrook, who are another Scottish business as far as the injection molding of the case is concerned. It's quite an important part to make sure that the finished product actually looks the part on the one hand and is also cost effective as far as the casing is concerned. And we worked with Eurofins when it comes to the conformance testing and the compliance documentation that was required. And really what we wanted and what we needed is we needed a device that was aesthetically inoffensive. And I say that as somebody who has seen and has worked with a number of IoT devices. Many of them seem to be made by engineers for engineers rather than being something that you would put into a residential environment. We wanted it to be unobtrusive and easy to fit, easy to retrofit, to power, and also easy to change batteries if it is battery powered. It has a USB option also, so if there's permanent power, USB power available, then you don't need a battery for it. And so with that, basically, what we tried to do is actually find a device or create a device, because there wasn't one in the market that met our requirements, and also one from a cost point of view and capability point of view that did everything we needed it to. So this device does the table stakes, if you like, when it comes to temperature and humidity, but it also does noise, it does air quality, light, motion, and actually air pressure as well, although we haven't used that in a sensible way for any of our customers as yet. But that's the device, and from a cost point of view, it was important for us to be able to actually have a product that would enable us to actually service our particular target market. So how did we get there, and what was the process, if you like? And I've drawn up two timelines here. The first one is the timeline from when we actually initially created the device. And it started in November 2020 when we had a kickoff with the team of experts that came together. We did some initial work prior to that with CENSIS, to actually work on the concept and the ideas. But this is when the whole thing started actually properly. And we then went through a process of having prototype boards built and tested, doing a pre-compliance check to make sure that the device doesn't kill anybody. I mean, that's basically it when it comes to the CE testing, the safety testing, and so on. That's part of it. We had to order the tool that does the injection molding. And I don't know if you're familiar with that process and what it looks like, but basically it's a block of steel, a cube that is about 400 mil cubed, which is not insignificant in weight and in cost. And basically you have to mill that out and actually provide all the moving parts to create the 4 components that actually make up the casing for it. That was made in China. And pardon the carbon footprint, it was actually air freighted over at the time because we needed it, and we needed it quickly. It was about 400 kilograms in weight, that particular piece of equipment. We then got our first plastics in March 21, and we started experiencing the first component supply issues actually in March 21, and I'll come back to that because this is a recurring theme and one of the challenges when it comes to actually developing and building your own hardware. We did the compliance tests in April, and we did the first proper build and test at the end of April and started volume production in May 2021. So that whole process took us about 7 months, and that was for a company, and certainly for me also as somebody who's never actually developed hardware, that was a ride, should I say. It was quite an interesting process, but actually getting there, it took quite a bit of effort and quite a bit of time. But we did that, I think, within a respectable time frame at that point. But as you will all be aware, we then had the component supply issues, and one of the key components that is actually built into that first version of the device became unavailable in the market globally. We couldn't get it anymore, and at that point it became very clear that if we wanted to continue making those devices, by that time we had manufactured about 1,000 of them, that if we wanted to continue making them, we would actually have to change, so to speak, the heart and the brain of the device and the firmware with it. And we then started the whole process again in October 21. And I'll not bore you with the details, but basically by the end of March, we started volume production. So that's the end of March this year. And so far, we've produced about 4,000 devices in that way. And we have a strong forward pipeline, order pipeline, as far as the production is concerned. So as part of that process, and I'll just show some pictures, you know, on the very top left there, you see the very first prototype of devices that we had that was built into a standard surface mount box with some holes drilled into it and the electronics put into it. The second picture is, you see one of those cases burning. That shouldn't happen. And basically what happened is the first the first plastics we got out of the tool, and that was actually done still in China at the injection mold manufacturer. They had used a material that clearly was flammable, and so that raised some panic questions and then some conversations. The way that the device actually sits in the recess fitting is using some magnets, and this was a Heath Robinson approach of actually proving and testing how many magnets were actually required to keep the device in place. We had some gas sensor testing where we tested a variety of different devices in the controlled environment, which is a tub from the kitchen. And then you see, you know, just an exploded drawing of the various components that actually make up the device. Some challenges that we faced, and as you can see, there are quite a few, and they're multifaceted. We had some component performance issues that we needed to address. Time is always a challenge under pressure, especially when you have things that need to run in sequence, and one thing pushes out the next. From a firmware point of view, like I said, especially when it came to having to basically redesign the device, the firmware had to be completely changed to associate you know, the functionality with the new device. Quality assurance and snagging is a constant thing. We're making you know, small changes to various parts of the build process and some of the components, like length of screws and different things, just to make it easier to actually build. Component availability in the center was absolutely a headache for us and added significant cost to the process. Then redesigning effectively a device for the component availability and selecting devices and actually dismissing devices that for some reason were not going to be available, or where the forward production capabilities were unsure. Cost and cash flow for a small business is always an issue. Excuse me. And then we had to redo effectively the conformance testing because we changed the radio parts of the device. And something that is also clear is that when you manufacture, you have warranty responsibilities, and that's something to be aware of also and build into the cost stack. Some other considerations, we actually went through the IASME certification process for IoT security. We had full confidence that we would meet the standards there, and we passed the first certification, the self-certified one, as a gold certified device with flying colors, and we just went through the level 2 audited certification and completed that process a few weeks ago. For us as a business, a device is only part of the overall solution, and we do everything to actually ensure that our processes are digital. So that includes the factory testing, the making a device live and giving it its credentials effectively, the onboarding of a device when it's actually put out into the field, and the installation as well. One thing for us now that is becoming real is the requirement for internationalization when it comes to the radio devices, and with that also, you know, as part of the redesign, we've tried to minimize the effort required for that. And packaging, if we sell in retail, which we don't at the moment, will become a consideration for us going forward. So what have we learned? We needed, and I believe we've managed to create an attractive product that is fit for our target market. It takes 90 seconds to install. It takes 10 seconds to change a battery. You don't need a tool for it. It's cost effective. It's a standard LoRaWAN device, which means that it could run on other platforms and networks as well without any problem. And for us, it's a vital part of our company proposition. Hardware manufacture, really, if I'm honest, is a necessary evil for us. And if we could avoid it, we would. But we felt that this was absolutely necessary for us. Having a great team is essential, especially when you're novices in the hardware manufacture space. And we believe that we've done that and we've achieved that. And external factors have had a real impact on what we've done, through things like COVID, the Chinese New Year, believe it or not, and everything that it does, on that side of the globe, and then discontinued components also becoming an issue from time to time. In total, it's taken us about a month longer than expected and about 10% more in terms of the original budget that we had set. But it was a great experience, and we've had great support both from CENSIS and from our industry partners that we've worked with. And it's a product that really will help us in our market going forward. Thank you. And if you have any questions, feel free to come and find me after.